Welcome to the video lecture on stored or potential energy. In this one, we will focus on gravitational potential energy. The work done by gravity is often referred to as the gravitational potential energy. Gravity applies a force on some object with mass. It's an attractive force. In this case, it's pulling the object downward. Our object today is a basketball. That object undergoes some displacement, S, a change in height. So there's some force, which is due to its weight, mg, applied over some change in height, h initial minus h final. This is equal to the gravitational potential energy. We use U sub g, or delta U sub g, because that's how it is in the AP booklet. So in the textbook, we will see PE for potential energy. It's very important to consider the system when looking at potential energy problems. You need to look at where the bottom of your system is in order to find the change in height. For example, I'm sitting on my chair at my desk right now. In relation to the chair, I have a potential energy of 0 because I have no height off the top of the chair. But in relationship to the floor, there's a height between me and the bottom of the floor. I could have some potential energy. In addition, in relation to the ground outside, I have a completely different potential energy. So it's important to consider where the system is and what is included. We will always keep the acceleration due to gravity, g, as 9.8 meters per second squared, because this really does not go into any change, or does not change at all until at heights after 100,000 meters. There are other types of potential energy besides gravitational. There's also elastic potential energy. This can be due to a spring or a rubber band. And there's electric potential energy due to the Coulomb force. Both of these we'll look at later on in the year. As mentioned before, energy is a scalar quantity since we don't have direction with it. Other than that, there are just some last little tidbits on gravitational potential energy. As I mentioned, we will be using the symbol U sub g, or delta U sub g, because that's what's in the APB formula sheet. The idea that potential energy is due to the height of an object makes you believe that potential energy, gravitational potential energy, only depends on that point or that object. It really depends on the relationship between two different objects. So just another little idea. Once again, energy, all forms of energy, is measured in the joule. Mr. Wolf picks up his little cousin, who has a mass of 27 kilograms, over his head to a height of 2.1 meters above the ground. Mr. Wolf has wonderful little cousins, and he has a whole bunch of them too. First, how much work did Mr. Wolf do in picking up his cousin? Second, how much potential energy did his cousin gain to have at that point above his head? And third, why is it important to understand the system before calculating potential energy? Think about what could be involved in the system and particularly the height.